of Agrophysics of Police Academy of Science, Lublin, Poland. And his focus research is on physical property of plant material, mechanical property of granular materials, and their influence of pressure distribution in silos, and discrete element method, modeling and physical properties of agricultural material, and food powder for safe and efficient storage, handling, and processing, and so on. Prof. Joseph Horebic, PhD, has published his research in more than 80 articles in TCL journal, and he is active as editor-in-chief at the Journal International Agrophysics. So if you want to publish our research in the Journal International Agrophysics, maybe we contact Prof. Okay, it's summary CP of Prof. Joseph Horebic, PhD. I want to know, if you want to know more than about Prof. Joseph Horebic, maybe we can read on his research, or maybe we contact Prof. Joseph Horebic by email. In this session, Prof. Joseph Horebic, PhD, is going to present on his research with entitled Discrete Element Method Modeling of Processes Important for Biosystem Engineering. And this time we give to you, Prof, on 30 minutes, and then we continue to our question and answer session. It's your time, Prof, please.
Okay. Thank you very much, Mr. Chairman. So as you mentioned, my presentation will be about the discrete element method modeling. The content of my presentation will be as follows: a few words about the biosystems engineering. Next, I will focus on the discrete element method, particularly on the contact models and with special attention paid to bonded particles model. And next, a few examples of application to biosystems engineering, for example, soil tillage, seeding, harvesting, post-harvest operation, and I will finish with some conclusions. Biosystems engineering is a branch of engineering that applies engineering science to solve problems involving biological systems. It integrates engineering science and design with applied biological, environmental, and agriculture sciences. Biosystems engineering.
Excuse me, Prof. Your slide still in first slide.
Excuse me?
You still in first slide, sir.
Well, on my screen, I see the slide number
3.
Number 3, yes.
But in our screen, still in position in number 1, sir.
Okay. So maybe I should start from the beginning. I will stop to share the screen.
Yes, Prof.
Okay. Excuse me. Sorry. Okay. Which slide can you see? Number 3?
Yes, Prof.
Okay. Thank you very much. I'm sorry for these problems. So, continuing my presentation, I'd like to say that agriculture and food processing are among the biggest producers of final products that are in the form of granular materials. Agriculture, food engineering, harvest, store, handle, and process a very big amount of particulate materials of biological origin. Unlike mineral or plastic granular materials. These materials are usually hygroscopic and change their mechanical properties through the absorption of moisture content. And to predict behavior of those materials, researchers have developed several scientific methods of investigations: empirical, semi-empirical, analytical, and with progressive of development of numerical methods, for example, the finite element modeling, which is still a continuum numerical method. And a new method that overcomes the shortcomings of empirical, analytical, and continuum numerical method is the discrete element method, which was developed by Kandal and Strack over 40 years ago. And the method consists of approximate solution of equation of motion of each particle represented numerically and identified with its specific properties such as shape, size, material properties, and initial velocity. 40 years of development of this method proved its high applicability in numerous branches of science and technology, such as physics, civil engineering, material engineering, agriculture engineering, food science, pharmaceutical engineering. There are a few examples of application to different materials: soil particles, for example, seeds, fruits, fibers, pellets, generally powders, and processes which can be modeled with this method: soil tillage, storage, handling, and processing, next to milling, agglomeration, and so on. A few words about the basic calculation of this method. The source is computational loop, which consists of a few steps which are repeated for each separate particle in very small time increment, approximately about 1 million times per second. Simulations starts with setting the initial position and initial velocity of particle. Next, the contact detection is performed. This is very time-consuming procedure, as it increases with number of particles in power of 2. Therefore, very advanced methods were elaborated to reduce the computational time. In the next step, the contact interaction forces are calculated. And in the next step, the gravity and fluid drag forces are introduced. And finally, we obtain the force and moment exerted on each individual particles. And in the next step, with application of Newton's law of motion, acceleration is calculated. And after integration, velocity and new position of particles calculated, and the procedure is continued again in the next step of time. To perform correct calculation, the contact model of interaction between particles and the working tool is very important, and it's very helpful to calculate this interaction separately in the normal direction, tangent direction, and in the rolling direction. Generally, the elastic, viscous, and frictional interactions are necessary to be incorporated. Elastic and viscous in normal direction, in tangent, the friction should be introduced, and in case of the rolling movement, also the rolling friction should be introduced. Different contact models is necessary to be applied to different materials or to the same biological origin material, but with different moisture content. And for example, for the dry grain, elastoplastic contact model is very useful. It means that deformation starts as the elastic, next the plastic deformation appears, and unloading goes along to the elastic formula. This is not convenient to use this model, as the loading consists of two different equations and unloading also with two different equations. So viscoelastic contact model is much better, which can be can be used for the wet grain, and with one equation, with the dissipation proportional to the velocity of the movement, the loading unloading loop represents the dissipation of energy. In case of the real materials, for example, wheat grain, we can observe from the experiment a very big loop, which represents the dissipation of energy independently on the moisture content of grain. In case of the small size particles, the adhesion forces should be considered in DEM simulation. Adhesion may originate from several sources, including van der Waals forces, electrostatic, or liquid bridge. Increase in the moisture content increases rapidly the adhesion. The theory of adhesive Hertzian contact was formulated by Johnson, Kendall, and Roberts 50 years ago. For particles larger than a fraction of millimeter, the most important source of adhesion is a liquid bridge between particles. And for these bigger particles, the linear elastic plastic contact model with the linear cohesion is most frequently applied. Agriculture granular materials present a very wide range of shapes, from nearly spherical to ellipsoidal or to concave particles of fluids and tubes. And the complex shape of particles are often modeled for DEM application by clusters of rigidly joined spheres. This method is known as the multisphere method. And this method got a very big application for seeds and generally speaking for agriculture materials. We can see that for wheat, maize, rice, and the other seeds, as well as for a straw model can be modeled with this multisphere method. The last 2 decades brought new and advanced method of modeling by introducing so-called bounded particle model. The method was introduced by Potiondi and Kandal. The model is based on the beam theory. It means that particles are connected by the beam, which can transmit both force and moment up to limiting value of the tension and bending strengths. So this approach provides good approximation of behavior of elastic beam, with particularly it can predict exactly the yield location, and yield threshold. Very important point of the discrete element method is the calibration of them parameters. And some of the basic parameters can be determined experimentally in physical experiments, like modulus of elasticity, friction, restitution coefficient. I mean, experiments with a single particle, if the particle is enough big, or in the experiments with the bulk of particles. But in the more advanced problems, some combined calibration method should be applied. I mean, experimental test and simulation. Comparison of these two methods in the same time can provide answer of bulk micro parameters and processes. For example, the formation of natural repose cone, bulk density of free-fall bedding, compression test, and so on. And after performing the calibration, we can start to model any process. So now I'd like to briefly to show modeling of some typical processes important for biosystems engineering. Let us start from the soil and impact of the cohesion. In case of the zero cohesion, we can observe
Excuse me, Prof. Joseph.
Yes.
Are you still in the slide content?
I'm in slide 16.
Oh, I don't know. How about on to the another participant? Is same with me on the slide, Prof. Joseph still in the content? Please help.
Yeah, still side content.
Okay.
Maybe Prof. Done by slide so.
Okay, I'm very sorry. So I will stop sharing this presentation,
Yes.
and I will start from the beginning. Sorry again.
Sorry, Prof. Thank you.
Okay. Okay. What do you see right now? Slide number 16?
Yes, Prof.
Okay. So on this slide, I'd like to show effect of cohesion on the particle behavior. So presented by Tsuji et al. This slide indicates strong impact of cohesion on soil particle behavior during pushing process by bulldozer blade. Okay, I switch to slide number 17. Can you see the slide number 17 right now?
We saw the slide 16.
I'm sorry again. I don't know what is wrong with my computer. So Okay, I shifted to slide number 17 but I'm not sure. Do you see the proper slide or not? But anyway, I'd like to shift to the problems of soil tillage and in case of the soil tillage, the size of particles assumed in DEM simulation influence quality of the reproducing of real processes. So smaller size, a better approximation. We can see the images of simulation for the small size particles and the higher size particles. But smaller size means much more particles needed for simulation. So it's very time consuming. But anyway, with the enough big number of particles, approximately 1 million, it is possible to model right now with the advanced software and hardware. Some practical application can be obtained. For example, no tillage seeding operation can be modeled, and proper size of the opener geometry for this kind of size of tillage can be obtained. And particles can be modeled in different way. In case of the soil, which consists very internal structure of the particles. So sometimes a few millimeter particles can be considered as the one particle of the DEM modeling, but sometimes we need to look inside such an aggregate. And this slide provides the behavior of soil aggregates, which is composed of the soil silt cemented by kaolinite. So this is the photograph of the structure with increasing amount of the kaolinite, which fills the pores between particles. The strength of the such a aggregate increases considerably, and as it was shown, DEM modeling can provide exactly the stress deformation relationship, and particularly the profile of the damage of the material. And now let us shift to another process, is storage of granular materials. The simplest process is the discharge of seeds from the silo. So for dry seeds, the elastoplastic contact model applied. For wet seeds, viscoelastic contact model. And we comparing these two graphs, we can see that for dry seeds, a very big scatter of results was obtained, but much smoother line was obtained in case of the viscoelastic contact model. And comparing with the DEM modeling, we can see that both processes for dry and wet seeds can be modeled. DEM was provides also very useful information related to designing of the storage silos, and some equipment which is necessary to provide smooth discharge is the silo inserts, and DEM can provide very useful information concerning loading exerted on the inserts, and also the information concerning the pressure distribution related to the silo operation. One important point and the most danger point of the process of discharge is the initiation of discharge. Granular material does not start its movement immediately in the entire silo, but the so-called rarefaction wave propagates from the bottom to the top. And during the propagation of this wave, the particles below the front of this wave is moving, but the stagnant zone is still upward. And this is related with very high pressure switch on the wall of the silo. So it is very danger moment. The speed of this wave is about 50 meters per second. So them is very useful for providing deeper insight in this process. Another process successfully modeled is the commingling in bucket elevator, segregation and mixing of grains. So again, experiments performed for soybeans proved very good agreement between experimental and simulated results. It means the uniformity of the mass of bulk of seeds with time of the elevator mixing. Another example, handling of the materials and bruise damage of apple seeds. Schaffer et al. Showed that bruise damage of apple seeds during repeated impacts loading can be effectively modeled with use of the viscoelastic contact model and with the multi-sphere method. Bruise volume increases almost linearly with the peak force exerted on that particle. And another important process, harvesting and desteaming of grapes. Grapes are modeled as the spherical particles, but the steam are modeled with the application of the bonded particle model, and them proved to model properly the commercial work of the commercial desteamer. Another application, harvesting, grain straw separation, grain modeled as the spherical particles, straw as the segments connected by the BPM model. And again, we can see good approximation of experimental results by them simulations.
Joseph, we now show only the slide 17.
Oh, I'm sorry. I don't know what is wrong with my presentation. I'm very sorry. So, well, I'm afraid that I cannot improve this. So
now is slide 28.
28.
Yes.
Okay, let me try again.
Also, slide 28.
Okay. Okay. So this slide is about compaction of fibers, but anyway, the time is going quickly, so I will come to some final slides. Well, another important part of modeling is the processing and the determination of the strength of the, for example, pellets. This method was appeared to be very useful in modeling of the objects treated as the BPM particles, I mean, connected by bonded particle models. And this concerns both the, for example, the starch tablets and some different behavior, for example, ductile, semi-brittle or brittle behavior can be modeled with this approach. And coming to the final remarks, I'd like to say that there are still some challenges in improving efficiency of the modeling. The very complex behavior of biological materials and strong dependence of properties on moisture content requires development of more advanced contact models capable to describe better dynamic of the processes. And for sure, advances in them and finite element method coupling are needed to improve, for example, multi-scale modeling of practical scale problems, and advances of them and computational fluid dynamics coupling would improve modeling of processes involving interaction of discrete particles with gas fluid phase, such as fluidization, pneumatic conveying, and heat transfer. And coming to conclusions, I'd like to say that DEM has proved to be effective in studying numerous technological processes in biosystems engineering. It allows insight into mechanism of stress transmission in granular solids that enables investigation of effect of properties of individual particles on behavior of bed of particles, and particularly the bonded particle model reproduce many features of behavior of solids like elasticity with ultimate yield, hardening, softening, and fracturing. So thank you very much for your kind attention, and I'm very, very sorry for the disturbance of my presentation. So I couldn't improve this during the presentation. I don't know what happened with my computer for that time. Thank you very much.
Okay, thank you very much, Prof. Joseph. Now, to all of participants, please, we hear the next presentation from Prof. Joseph. Now, please to give question to Prof. Joseph, please. Ladies and gentlemen, please.
Hello, Joseph. I am very glad to see this part of your presentation. I think that it is very high-level modeling of many processes, and I congratulations to your company and also to you, because I saw it is a very, very great work, and I hope in the future I will see all the presentation, and it was very, very interesting. Thank you.
Thank you.
Dear Professor Hlavatova, thank you very much for your kind words. I think this method is very promising tool for the future, and we are glad to be able to participate in this progress.
Okay, dear ladies and gentlemen, any question again to Prof. Joseph? Didn't? Not yet? Maybe on presentation Prof. Joseph is on more clearly. So not any question. I hope the conclusion from the Prof. Joseph to give our participant, please, Prof, on ending session remark. Anything on Prof. Joseph we want to say to our participant? Prof. Joseph?
No.
No, enough? Okay. Thank you, Prof. Joseph, for the nice presentation. And
thank you very much.
Our session is on. We will end, and I give turn back to my Master of Ceremony, Miss Tati. Miss Tati, it's your time, please.
Thank you, Mr. Seres and Mr. Pardede. I'm sorry, Mr. Horabik. Now, Excellencies, ladies and gentlemen, here we will have the parallel session. And for those who join the parallel session, please join to each room.
Okay, our next keynote speaker is Professor Isvan Seres. Professor Isvan Seres, are you there?
Yes, thank you. I'm here.
Okay, thank you very much. Thank you very much. And good morning in Hungary. Yeah.
Yeah, thank you. Okay, I just share my screen.
Yeah.
Be able for you my presentation.
Yeah. Professor Isvan Seres is from Hungarian University of Agriculture and Life Sciences. Without any further delay, I would like to invite Professor Seres to deliver us with the presentation. The floor is yours, Professor Seres.
Thank you very much. Could you give just some feedback that can you see my presentation?
Yes, I can see your presentation.
Okay. Thank you. So, dear colleagues, ladies and gentlemen, my name is István Seres and I'm working in the Gödöllő in the Hungarian Agriculture and Life Sciences University. And our department is working a lot with different renewable energy sources, mainly with solar energy with the leadership of Professor Farkas. And now I would like to show you a few work about what we did. Actually, I was thinking a lot what to do when I was watching the topics of the conference, that we do different project work with microcontrollers as well. But I think the solar energy is most dominant for our department, so I decided to give you some impression about our work on that field. Actually, what mainly I would like to show you that we installed a 10 kilowatt peak photovoltaic system on the top of one of our student hostel buildings in 2005. Here are some just pictures from about the construction of the site. And here you can see some different datas. That time, this was the biggest Hungarian photovoltaic system. Of course, since that, the technology is improving very fast, as we could see from several presentations, how big is the improvement. We can see it in our university as well. Now, altogether, we have 600 kilowatt peak installed on the roofs. And even in Hungary, we have some bigger constructions, mainly operated by professional companies. Even me, I have a small system in my house as well. So why I was choosing this old and relatively small system? Because we could collect a lot of consequences about the working of it, and perhaps this can be interesting about the aging and how the power is changing and what sort of factors we can see. First, just let me show a few details about the system. Altogether, we have 150 square meters of modules. Most of them are Hungarian-made amorph silicon Dunasolar modules that companies not working already in Hungary, and a smaller fraction of the system is made of German polycrystalline modules. Here you can see some details about the size of the system and the numbers and the power. I will give you a few words about the newer system, which is a transparent module, semi-transparent module system in front of our aula building. There the capacity is much less, 3.3 kilowatt peak. That is a demonstrational system, not really for energy production. Of course, we produce energy with it as well, but we wanted to meet the students every day with this technology because the other systems are on the rooftop, so they cannot meet with them. And of course, in our research lab, we have different smaller modules, different testing sites to check the technology. We did different measurements. Oh, sorry, I'm just not sure that you can see my whole figure or not. I hope so. So we have different, we did a lot of different measurements. Even in the education, we have these measurements during the physics lectures, that the student has to measure the characteristics, the IV characteristics of the modules, and calculate the maximum power can be get from that module, that given module. And even we can show them why it is important not to shade the modules, because if we just shade one cell, for example, then the module power coming down very drastically. So these figures are showing the effect of the shading under different geometries. Of course, these all types of module, they just had one bypass diodes. In the newer ones, more diodes are installed, and it can decrease this effect. On the other hand, we were investigating, or we made a comparison of the different systems, different technologies as well. For example, as I showed you, in this system, we have polycrystalline and amorph silicon modules as well. Of course, the direct comparison of the energy production is not the best because they have different nominal power. So what we did, we defined a so-called specific power, which specific power is the actual power of the system divided by the nominal. So we watched that 1 kilowatt peak of module capacity, watt power, with watt power is working, or how many energy is produced by 1 kilowatt peak of modules. So the energy production was divided back with the nominal power of the system. In this way, we got specific power and specific energy production, and we checked the rate of these productions. That means that 1 kilowatt peak of polycrystalline powered energy was divided by the energy production of 1 kilowatt peak of amorph silicon. And what we could see, this is data of long years, what we could see that there is a seasonal effect in this function. Of course, yeah, in Hungary, I'm not sure if you know it, in Hungary in the summertime we have generally above 30 degrees, 35, and in the winter time sometimes we have -10 as well. So surely there has to be a temperature dependence in the problem, but we saw that there is a spectral dependence as well. That means that in the winter time the solar radiation has to cross much wider air layer, and in this way the spectra is changing. So we made some spectral measurement. We have a
inputra or Sterwin.
oh, sorry. Okay, I saw that there is a problem somewhere. Okay, so we have a spectrometer. I just show it in this way, and the spectrometer can measure. Yeah, it's not a very wide range, but it can measure from 400 nanometer to roughly 1050 nanometer the distribution of the incoming light. With the spectrometer, yeah, perhaps we are online. I think I can show you some demonstration as well. Just one more moment for that one. Oh, sorry. I cannot start my. I just want to start the software, but I cannot at this moment because it's not running. Oh, it's a shame. Okay, perhaps if we have some time in the end of the, because I cannot use my computer, so I could not reach my software at this moment. Okay, no problem. I did not used to use the Zoom, but in the end of the presentation, perhaps I will show you if we will have time. So with this spectrometer software, we can analyze the incoming light, I mean the power distribution. Actually, this unit is calculating the photons, how many photons were coming during a given time. This time can be adjusted in a special wavelength range. And in this way, we can measure what is the spectra of the incoming light. And we were using different sheets to cut a part of the spectra, different colors, we can say. And even we were measuring the incoming radiation coming to the photovoltaic modules. And we were measuring the reflected radiation spectra. And from the difference of them, we could analyze which type of spectra is absorbed by the module. So we were analyzing the spectral dependence for the different technologies. For example, for this given example, what I showed for you, that there was a seasonal effect in the rate of the different technologies energy production. We could see that the amorph silicon modules are more sensitive for the red and infrared radiation than the polycrystalline ones. We did a lot of measurement, and some students' work, some diplomas was made of this. So I think it was very useful for the education as well. As I mentioned, this is an old system, and what is the reason to use an old system? That is to check the degradation. It's a big question. Of course, I know that the producers are using artificial aging, and they want to test their system, what can be the reasonable lifetime of these products. But no, in our system, we have actually, at this time, we have 17 years old modules installed, or even older, because some of the modules was bought earlier. We did not have the total money at once, so we were collecting the modules for years. And so we can say that almost 20 years we have these modules installed at the same place. And under Hungarian conditions, I think this can give some good results for the aging. The energy data, of course, we are measuring different data. We are measuring continuously the energy production. We do not measure continuously the power, but we save energy data in every 10 minutes. Here you can see how much was the, this is the date and the time when that measurement was done. This is the identifier of the unit. And these are in kilowatts, the energy production of the different subsystems. So these measurements is running continuously, and we are measuring the DC side, and even we have a special meter measuring the grid. And on that side, we are measuring the AC side as well, how many energy was fed into the electric grid. And we use a three-phase system, so the three different subsystems we use goes to the three different phases. So in this way, we can measure separately how much energy was taken during that 10 minutes to the grid. So from these data, we can calculate 10 minutes average power for each subsystems. Of course, we try to get, or we try to check if how much is the degradation of the system. This degradation is normal, I think. If you buy a photovoltaic system, for example, I installed one, as I mentioned, on the roof of our house last year, and the warranty was that these modules will have the 85% of their initial capacity or nominal power after 20 years. How we can check it? Okay, we checked it in our system. This is the daily energy production of our system. Here you can see very well the seasonal changing. Sometimes we had some data loss, a bad disaster, so the system was working continuously. These gaps are not the system fault, but they are just data loss of the system. But as I mentioned, we measured these data for the different technologies separately. So this was giving the basic of our analysis. And so as you see, we did some measurement and we made some yearly analysis of the data, how much energy was produced from year to year. At the beginning, it was very regular. I mean, in every end of the year, I was coming here. In the later time, it was not so regular, but it was working continuously. So we can go, or we can say how much was the total energy production during the operation, and even we can calculate how much was in a given period. So in this way, we made a comparison of the different subsystems. In this slide, you can see the differences between the two dunasolar subsystems. These subsystems are theoretically identical. However, one part of it is slightly higher than the other part. Yeah, in the last period, we had a phase problem that we could not recognize it. That is the reason why I did not use this in my calculation. Yeah, they are identically the same, or theoretically the same, but of course there are some slight difference between them. What can be the reason? Yeah, we know that the nominal power of these modules, but even during the tests, that I think because of the production, there are a few % of differences between them. And one problem can be that we have rows of modules. And in the winter time, of course, partly these rows are shadowing each other. However, we were calculating that the shadowing would be minimized, but in the winter time, it's not possible in the morning and in the afternoon because the sun is going so low degree, small inclination degree. So there are some shading that period, but not in the first row because it is in the top of the 4-story building. So that can give a difference between them. But I think they are working more or less together. The other, perhaps more interesting, if we compare the polycrystalline technology and the amorphous silicon technology. Here the difference is bigger than in the case of 2 dunasolar rows, but the polycrystalline technology subsystem has bigger nominal power. So that is normal that it produces more energy. But if we compare the specific powers, we just made a rate of the comparison. We compared the rate of the polycrystalline technology and the average amorphous silicon technology. And in statistics, after 70 years, we could see a definite decline in this rate. That means that, yeah, the dunasolar, or so the dunasolar is the amorphous silicon over the polycrystalline. So it is decreased. That means that the rate of the polycrystalline technology in the energy production is increased. I just show it in a different slide. In this slide, you can see what is the rate of the polycrystalline technology in the total energy production. And yeah, what we can see that it is going from about 40% to 43 point something %. So our conclusion was that the amorphous silicon technology degraded more than the other modules. Yeah, of course, each of them was degraded in a given scale. What can be the reason for it? So we are checking regularly the system, and these are the ASA, the polycrystalline modules. And on that way, when we checked the system, there was no any sign of degradation. So visually, we could see nothing. Of course, what you can not see by eye, that there is, for example, the effect of the UV radiation. Ultraviolet radiation is damaging the material somehow, but you cannot see it. So I think the polycrystalline modules are okay. What we could see that during the construction, they did not use the rust-free screws. So that was the only problem we should repair. But it does not have effect on the working on the system. After that, we were checking the amorph silicon technology as well. We could not see colorization. The junction seems to be okay. There are no hotspots on the system. But what we could see that I think because of the production technology, in the bottom and the top of the modules, some air was going in. I think the insulation material is not the best. So between the module surface and the glass cover, there are some air bubbles. And of course, these air bubbles will decrease the useful energy, because when the light is coming to this region, then because of the total reflection, you can know it from the physics, a big part of the light is reflected back. As you see here, when we see the black color of the module, that means most of the radiation was absorbed. Yeah, of course, from the glass we have reflections. You can see even here the clouds. But here, the biggest part of the light is reflected back from these air bubbles because of the total reflection. And of course, if it is reflected back, then it cannot go to the absorber surface of the module. That means that this part is not working properly. In some cases, we could see this effect almost in all rows, and in other cases, it was very, very partial effect. This is a photo of the system from before, and you can see that in the middle of the field, very few module is affected, mainly in the sides, generally in the sides of the system, and in the black part of the system. I made an analysis. This is the last row. In the last row, almost every module is affected. But if I go further, just the side modules are affected. We were thinking, yeah, these are the numbers. This is the source direction, and this is the north. And in the rows, in the north part, are affected in high range, and the rows in the front size in the south side of the system of the field is affected less. And even in these rows, mainly the side module, which are in the edge of the rows, that are affected. So we were talking about what can be the reason for this, and we concluded that probably probably the wind direction in Hungary and in Gödöllő as well. The main wind direction is from north, and as the wind is coming, in some cases we have quite strong wind. These Duna solar modules, I'm not sure that I have a photo about it. Oh, no, not. These Duna solar modules, the fixation point is somewhere here. And of course, if the wind is coming and some turbulences are developed, then it is moving continuously, I think, the three sides of the modules. This problem does not come for the polycrystalline, because the polycrystalline has a frame, and this frame does not let to move the module itself, but not for the amorph silicon. So the fixation points, there are 4-6 fixation points somewhere here. You can see the holder rod behind, and this is a glass. If the wind is coming, it can move a little bit slightly. Of course, you cannot see by eye, but I think that can move, and that is the reason why the side modules and the backside modules from where the wind is coming are mainly affected by this problem. So we predicted that this calls for us about 4% of energy loss continuously at this moment. Yeah, perhaps we should try to re-insulate some modules to see that it stops, or we can stop it or not. That is the next question. Okay, to go ahead, beside the quantity questions, sorry, I have forgotten to take my phone to silent mode, but I did it now. Okay. So beside the quantity question, we tried to see some quality questions as well, because as we are using more and more electronics, the grid quality is an important question as well. Traditionally, our electric grid is powered by generators. Yeah, I teach physics, so in every presentation I have to take some physics. In the generators, we are rotating coils, and in these rotating coils, the flux is changing continuously. We can write the electric or the magnetic flux of this coil, and as it is rotated, the time derivative of this flux will give us the voltage. But as in the flux, the angle of the magnetic field and the angle of the coil is important, and this angle is changing continuously. Actually, the surface perpendicular component to the magnetic field is important in this case, and it is changing as a cosinus function. But if we derive this function cosinus, then we get a sinus, and in this way we get why in the electric grid we have a sinus function, and yeah, the magnitude of this function is important as well, but the periodic time is important as well. Yeah, the reciprocal value of this periodic time is the frequency. That is what is very important for the working of, yeah, not all, but some units. This frequency in Hungary and in Europe is 50 Hertz, but it can vary in the world. In America, for example, they use 60 Hertz as a grid frequency. So actually, we made with students a very simple measurement circuit. To measure this sinus function is not so easy because it is changing very fast. You cannot check it with a multimeter. If you met with an oscilloscope, with the oscilloscope you can visualize it very easily. And even with newer oscilloscopes, you can save the data as well. But these types of oscilloscopes are not so cheap. So with students, we were using high sample rate voltage measurement with data loggers. But the problem that these data loggers can accept generally maximum 5 or 10 volts and an input voltage. So we were setting up a voltage divider, 2 resistances connected seriously. And from the physics, you can know that in the resistances, the voltages are proportional to the resistances in case of serial connection. So we were taking this unit, we were connecting the grid voltage to the serial connection of these two units, and we were measuring just the voltage of R2. If we use this 46 kilo ohm, then 0.46 kilo ohm, high resistances had to be used to avoid high currents. Then, yeah, it's roughly 1 to 100. Then the power rate or the voltage rate is 1 to 100 as well. In this way, we could measure how much is the voltage as a time function. We were using two types of units for this purpose. This is a National Instruments USB. It's a very simple one, which can measure with 48 kilosample per second. And we were using National Instruments MIDAC unit. This is educational unit for what the sampling frequency is 400,000 samples per second. And with these units, we were measuring, we used the LabVIEW software for collecting the data. And with this one, we could measure what is the time serial of the voltage. This is the measurement of the voltage of the grid in the physics lab. And with this one, we could check what is the shape of the voltage function for different inverters produced by solar energy. For example, this is a very simple inverter. We have a so-called solar use case. In this solar use case, we installed a few small PV modules, about 5 watts altogether, and a charger and an inverter. And this unit is borrowed for the scouts, and when they go to camp, they can charge their telephones and they can operate a LED or for lighting and so on and so on. For we checked the simple inverters. The simple inverters are not sinusoid generally, but the normal units, chargers and lamps are working with it. But the problem that I just check how many time I do have. Okay, perhaps I can stop for a while now, because I would like to show you something. Theoretically, this is an audio software. With this audio software, I would like to demonstrate for you what we measured. Actually, this is, I made a mistake. Don't problem, I can open it again. So I just play a sound for you. I hope that you will hear it. Could you give back? Could you give any feedback? Could you hear the sound?
No. We cannot hear.
Oh, it's really a shame. Okay, then this demonstration will just work by picture. Sorry for it.
Yeah.
The problem that, I cannot get the, So this is a sound of a violin. I'm really sorry that I could not demonstrate it, but I don't know how I should set my computer to be able to hear the sound of the violin as well. And this is, it was recorded and we can analyze it. Because the main question, if we hear a violin or if we hear a piano, we can decide which instruments sound we hear. However, they are playing theoretically the same sound. For example, this sound A, 440 hertz. And for that one, with this software, I can show you the spectra. The spectra shows what sort of frequencies was using in between. This is the spectra of the violin. I have 4 children, so they play different instruments. At this moment, we can see that yeah, this was about 440 hertz, but I could not find exactly the, yeah, 440 hertz. This is the peak, but we have 880 and we have 1320 and so on. So when we hear a sound, we hear the basic frequencies, and we have the double, 3 times bigger, 4 times bigger, and so on frequencies as well. If I open another instrument, yeah, this other instrument is a piano. Surely you would be able to hear, but at this moment, perhaps it's useless to play, but it's really that. And if I check the spectra, then in this spectra, we can see very different range, but the same. The basic frequency is 440, and we have a so-called harmonics. So the harmonics is generated as well when we hear a sound. And as the rate of the harmonics are different, we can distinguish which was the piano and which was the violin. So in this way, we can recognize what sort of instruments was working. Okay, this was about the sound. Now I'm coming back to my presentation. No, I don't want to say. So this is a spectra of the piano, and this is the spectra of a violin with a different software. So what we can see, what is the difference? The difference is the power rate of the harmonics. But these harmonics are existing for any system when we are generating periodic functions. Perhaps some of you were learning mathematics, and perhaps you have learned the Fourier analysis theory. In the Fourier analysis, it says that if you have any periodic function, this periodic function can be reproduced by a special sum of sinus and cosinus functions. This is the so-called Fourier serial. And even we have the rule how the multipliers of the sinus and cosinus functions has to be calculated. And what we see that in this case, I have to multiply the x by whole numbers. If the x is a given frequency, then I have the multipliers of x. So I have the harmonics. In this way, we can set up the spectra of any periodic function. In some cases, we have even functions. We call a function even when it is symmetrical to the y-axis. And we have odd function when it is symmetrical to the origo. As a sinus function is odd function and cosinus is even. In this way, we can use each. Okay, so I showed you that with a very simple data logger, we started to analyze the grid, but it was not enough to check the harmonics. So we were using a professional unit. This is an electric power quality analyzer, WALI free. WALI is the name of this unit. And our PhD students, Atsu Divine, was doing these measurements. This unit can measure the voltage and the current and even the phase angle between them. And it can analyze the harmonics and the rate of the harmonics in a given frequency. And what we were calculating the total harmonic distortion. It's an important quality property of the generated, where V1 is the voltage, maximum voltage of the fundamental frequency, and VI, where I goes from 2 to 40, is the voltage of the harmonics frequencies. Theoretically, the summarization goes to infinity, but the amplitude of these voltage functions are coming down generally exponentially. So after a while, we can eliminate it. A few words about this analysis. First of all, there are some standards for this one. How much can be, yeah, we have different standards, European and American standards. How much can be the harmonic content in the smaller orders and in the higher orders? And what you see, the odd components and the even components are different. I mean the limits. If we check the different standards, generally they say that the total harmonic distortion has to be below 5%. Why? It's not interesting if it's odd or even, because this is the basic frequency. This is the first harmonic. If you check the first harmonic, in the first harmonic, the frequency is the double, so the wavelength is the half of the original basic fundamental function. But in this case, the harmonic gives a positive and a negative addition in one part, so they more or less equalize each other. But if we check the second harmonic, in this case, in this 1/2 period, I have 2 positive and 1 negative range. And in the other side, I have 2 negative and 1 positive range. That is the reason why these harmonics are more strict calculated or more strictly reduced than the other ones. Yeah, this is the inverter and the measuring of the transparent system. We did a lot of different measurement, and here you can see the harmonic distribution, and you can see the total harmonic distortion of the system for the voltage and for the current. What we could recognize that under bad radiation conditions, the total harmonic distortion was higher, and under good conditions, the total harmonic distortion was in the limit. And we could measure the same for the big 10 kilowatt peak system as well. So we could say that the total harmonic distortion is below the expectations when the sun is shining well, but it can go wrong for our inverters. Of course, it's depending on the inverters under bad conditions. But if the condition is not so good, the radiation is changing, or the radiation is very low, then of course we feed very small amount of energy to the grid, so we cannot harm too much for the grid. But under good condition, when the energy surplus is big, then the total harmonic distortion is okay. That means that our systems do not harm for the grid. So the grid operators don't have to be worried about it. Okay, I think at 10 o'clock, so I finished my presentation. I was writing some conclusions, but I think I don't have to summarize it. I hope it was clear. So thank you very much for your kind attention. And I'm coming back for the...
Okay, thank you very much. Okay, thank you very much, Professor Sesi2. Now I open the question and answer session. Are there any questions from the participants? From the audience?
Hello.
Yes.
Hello, Istvan. Your presentation was very interesting.
Nice to meet you, Susanna.
Experiment, and the piano we heard the piano. All the violin note, but heard the piano was good. I have one question only. You said that you have also solar system on your house, and what is the amount of energy you get from the solar system? It is enough for your house or no?
Yeah. Actually, it's not exactly optimal. Its nominal power is 4.4 kilowatt, the module capacity. But the roof is facing a little bit to the east and south. So it's not exactly optimal. And even the angle is not optimal for Hungary. But even this way, it's not exactly, I do not have measurement data for 1 year because it was installed last November. So we have a month back yet, but I think with this one, I can produce, so the system produces roughly 5,000 kilowatt hour per year. But actually our electric consumption is less. It is about 3,000 kilowatt hour. Yeah, the children was leaving our home, so it was coming down. So actually we were installing now some climate unit for what we can use for cooling the house and heating the house as well. So the difference, no, we are heating the house with that one. Okay, one room with that one. So I think it's this amount of energy is fairly enough. I'm even hesitating to change my gas boiler to electric one. So I think a small system, and it is 13 modules, so it's not a big one, but it can really operate the house with electricity.
Thank you very much. Thank you.
Thank you.
Yeah. Okay, thank you very much. Since we have a short of time, I think we will close our session. I thank you very much for all participants and for keynote speaker. Thank you very much. And I will return our time to the organizer.
Okay. Thank you, Mr. Alexin and Professor Saras. Well, ladies and gentlemen, coming up to the next session, we are going to have a parallel session. For those who join the parallel session, please join to each room. Thank you.
Bentar. Ya.
ternyata.
Ya, udah. Gimana Pak? Udah oke? Halo, Assalamualaikum warahmatullahi wabarakatuh.
Oke, Pak Nasrun.
Nyari-nyari susah tadi ke atas. Halo, halo
Oke,
Pak.
Pak Nasrun,
Pak
oke.
Arif.
Udah keren.
Bisa dimulai nih. Aduh.
Tunggu dulu dong, sabar Pak Nasrun.
Oh ya, sok ya, silakan dulu lah. Dibuka dulu sama Pak Arif nih. Orang hebat nih.
Oh, wes. Senior yang luar biasa Pak Nasrun.
Ya ini coba nyoba, udah lama nggak ikutan nih.
Lot ini room 5, Lot?
Hah?
Pak Nasrun di room berapa?
Nggak tahu room berapa nih, nggak tahu saya.
Saya di room 5.
Room 5 ya?
Room 5 mungkin Bapak bisa ke breakout room dulu Pak, untuk bisa join di room 5 Pak.
Gimana nih?
Caranya?
Breakout room, Pak Arif, mohon klik breakout rooms.
Sebentar, klik yang mana?
Breakout rooms, ada di bagian bawah, di sebelah.
Breakout room, sorry. Record more, coba saya lihat more. Oh, join breakout room, oke.
Ya, lalu pilih yang room 5, join room 5 Pak.
Oke, join room 5. Oke, join ya.
Ya, baik Pak.
Yes.
Banyak.
Halo, Pak Nasrul. Hello, Donny.
Hello, Professor.
I see that we completed the session. And how about you? That the other one?
Yes.
Other session
Just completed with Susanna in the other room. The fourth.
Hello, everybody. Hello, Dan.
Professor Rabi.
No, I see that you a little changed the closing.
Hello.
Closing that it was originally.
Hello, everybody.
16 to 16:30. Because I have a. Yeah, I have 5 p.m. I have a meeting, a doctoral committee meeting, which is planned a long one. So I will have a short time. I mean, 15 minutes probably with that. How long you want to argue or going to speak? You personally. Half an hour? You want to speak in the closing?
Sorry?
How long are you going to speak for the closing?
I will ask to the Parliament Committee, Parliament or the Bunuha?
Yeah. Good.
Bunovi, Pak Jasman, Pak Jono. Professor Farkas, there is a meeting agenda. So
yeah,
if everything is okay.
But anyway, that's okay.
All right.
Ya, Pak.
Actually, it would be also nice if you announce that what are you going to have a deadline for the final paper, for the proceedings paper.
Yes.
What is your plan? To give an offer a deadline for the people.
Dr. Jono or Nuha, maybe you have information about the late of the paper, the latest of the paper for the paper.
Yes.
Next one more.
Deadline is important for everybody.
Sure.
We are pressed in time.
2 weeks after today.
Hello.
Hello. Hey.
Hello, Dani.
Hello. How are you? How are you?
Are also there.
I didn't find your paper.
I didn't send the paper. We have only together.
Sure. Okay.
Okay. Okay, thank you very much, Dr. Dani and Professor Farkas, Professor Horabik, and Professor Isvan Seres as well, Professor Luzana, and also Professor Lubomir Kobik, who has joined in and support our international conference, this FOITIC 2021. For the full paper submission, and we will divide it into 2 categories. Which is the first one is for the AIP publishing, and the second one is for our internal, or it will be published by our ITENAS publisher. I mean, it will has an ISBN number, but it will not index it by the Scopus. So to the all of the authors here, of course, for the first category, there will be a charge to publish in the Scopus Index proceeding. We will collaborate with the AIP publisher for this and for this category, and we do hope that for this first category it must be published by February next year. So next year it has to be published published online next February. So we really hope that for all authors who intended to publish in Scopus Index proceeding, because we will have a review and revision and something. So the first we are hoping that we will receive your paper, for your full paper, by next November, and then we will try to review and then revise, and maybe by January it will be all right, and then in February it have met the AIP publisher standard, because we have to meet their standard on publishing. It will take some time for it. So hopefully in 1 month maybe, for those who like to publish in Scopus Index journal, have submitted the full paper to us. Yeah. I'm sorry. Maybe is it by the system or by email or to publish to submit the full paper by system? Sorry. All right. Maybe it's much better for all the author to send the full paper to our email. Yeah, to our email. The email is foitic@itenas.ac.id. Maybe Ms. Nuha, could you please write the email in the chat room so people would know this email. And yeah, thank you. Maybe that's for the first category, and then for the second category, maybe it's a bit we have lots of time, but hopefully also for the second category, if it's possible, also in February we want to publish as well. So it's hopefully for it either for the first category or the second category, we are hoping that it will be published in February by next year.
Sounds
Maybe,
good.
yeah.
Sounds good. I think it's a reliable time schedule. Thank you.
Thank you, Prof. Farkas. Yeah, for all the corresponding about this conference, we will use the email for all our. If you have any question or inquiries, or we will use the FOITIC at itenas.ac.id as our main email. So please do not hesitate to contact us if you need more information about anything about this FOITIC, the proceeding and everything. Yeah. Okay. Dr. Dhani, maybe
okay,
we can go on to the session. Yeah.
Okay, thank you very much, Dr. Jano. Good afternoon, everybody. Professor Professor Susanna, Professor Horabik, Dr. Lugomir, Professor Seres. Now we have the time to, in the last session, in the second day of the FOITIC event, as the committee said, this is farewell, yeah, farewell. But I just want to remind for all of you that I just want to remind all of us that the FOITIC event has been started since 2017. At the time, we began with the international partner, St. Itzman University, the former of the Hungarian University in Agriculture and Life Science. And the second, we have two partnerships, yeah. And the third, we got a lot of the partnership. This is a great moment for us to get a lot of partnership. The first, I would like to thank you very much to the Professor Farkas, Professor Horabik, Professor Lubomir Kubik, Professor Seres, Professor Sana, and all the participants. Yeah, without all of you, I think we can do such kind of the great event. Yeah, just I want to give the opportunity to all the professor here. I think Professor Farkas, for the time, I will give the speech for you because you will meeting. Yeah, I know.
Thank you very much, Dani. And Dani is really a good leader of the university, not only as a former dean and the vice rector. he knows how to share the duties, so he gave over the speech for me. But anyway, sorry for that. I have an important meeting starting in half an hour. Another one concerning our doctoral school. As a matter of fact, I don't want to talk so long at the beginning when yesterday we opened that Congress or conference. Then I said already my issues. And what I would like to just give you the kind of short evaluation. So first of all, I think on behalf of all of us, we would like to say our deep appreciation and thanks for organizing that meeting again the third time, and especially for the faculty and namely to the Dean, Dr. Jonas Suhartono, and also the rector. She supported. Professor Melinder is not with us at the moment, as I see, but Danny, who is the initiator of the series, with us continuously, every minute spent with us. And so if I would say the evaluation, a kind of evaluation, I would say that that's the lectures and all those that I took part in personally, the sessions, it was quite reliable, updated topics, and the keynote presentations were sorted out in an excellent way. And what is important, very important, I think the organization was excellent. So if I could say the excellent lectures, excellent keynote presentations, but the organization was really very excellent. If I could say that all together, all of that aspects, if I take into consideration, I would say that this event reached the real the international level. So it's not anymore a kind of local conference. And this is what I think the continuation we had to keep in our mind, and you have to especially don't let it less than this one. I mean, just higher and higher, up and up. So this is the way how the Renaissance will also getting a higher and higher scientific position in the world. We are partners, personally, all of us who are sitting here now, and we were invited and having a keynote presentation representing institutions. And as Donny said, it's now extended not only towards institutes, more institutes, including enlarging the conference. And we are to the point when it became a real and international one. So this is the main point what I'm considering. So the continuation is definitely, for me, it's given. So this is a job again for you. And I think that whole level, as I mentioned at the beginning, not only the faculty, but also university level is very important. And just I would say that congratulations to all of you, and it was a great success. And let's hope also that, as Dr. Jono explained, that the publication will be, the proceedings will be also a higher level this time. I mean, that's also a very good one. I'm very much supported that one. And what I hope that some of the presented materials, what we heard here, finally initiated that all the young people, especially who are very important to having a high level publication. So this was starting point of the here presentation. They continue and reform it into a journal publication. So if those after that refer back to this meeting and also make it more visible, that conference is. So congratulations, organizational point of view, congratulations on scientific point of view. Go ahead. And as the famous sentence, they say the show must go on. Thank you very much.
Thank you, Professor Farkas. Maybe I forgot one about the statement. Previously, in the first FOITIC, we have decided that the FOITIC is the biannual program. Yeah. And we have choose also that the chairman of the FOITIC is the defense of the dean, but for the international chair, Professor Farkas forever. Okay.
Thank you, Danny.
Okay. Okay. Thank you.
But maybe as Danny said it, I would like to remind again that date when we first started to cooperate, it was 2006, so 2006. So it means if you are taking into account 15 years now, 1.5 decade, and the International Drying Symposium, but I organized here in Budapest, and you already attended with this work. So that's long-term cooperation. Okay, thank you.
Thank you. Thank you, Professor Farkas. Professor Yosef Arabic, maybe I would like for you, the opportunity to give speech.
Okay, thank you very much. Professor Dani Rusiravan, and I think it was very good conference. I'd like to wish you to keep the same level for the future, because it's very important to organize such a good international meetings for exchange of the experience between people from different countries, and also different areas of interest. So industry, agriculture, life science, and so on. So it's very helpful for everybody to exchange knowledge between different areas of science. So I'd like to wish you all the best for the future, and please keep this level of conference for the future, and I'd like to wish you all the best. Thank you very much.
Thank you very much. Yes, sir. Now I will move to the Professor Susana, and the background is the Peter. Hello, Peter.
Hello.
Yeah.
My English is not so good as Professor Farkas, and only shortly. I would like to, on the beginning, to thanks to the Dean of Faculty of Industrial Technology, Dr. Jono Suhartono, for the great event which was prepared on this faculty, and also to the Dr. Dani Rusiravan as a vice rector of the university for this conference preparing, and also to all people which organized this conference, because I think these 2 days was very useful for us and also very interesting. I can say also that the parallel session in which was I the chairperson was very great, very great, because the all presentation was interesting, and many new results held your participants. I would like to also ask you, the future years, we prepare in Nitra the conference of spring, and I hope we will see someone from this audience in Nitra, and I hope that the pandemic situation will be good, and we will meet you physically, not only online. And I also hope all the people will be healthy in this last year. I think also that say the Professor Farkas that the international level of the conference was very high, and I hope that the BPS Nitra will also have a high level, and the doctoral student in this conference will have nice presentation also. On the finishing, I would like to wish you and your university, your faculty, many success, and in the future. And I hope that this opportunity about we speak with Danny in the parallel room will be really in the future, and I hope also we put some close cooperation in the at the university in the Bandung. I wish you also all the best. Thank you for your attention.
Thank you, Professor Susana. Thank you, Peter. Supporting in background.
Yes, yes.
Now, I would like to give opportunities to the maybe Professor Seres or Professor Lubomir. If you want to say something, please.
Just a few words, thank you, Venice. So I would like to say thank you for the possibility of participating in your conference. I could hear very interesting presentations and a very wide range from the cancer detection to the solar street light. So it was really good, and I would like to congratulate for your students and colleagues for the very nice presentations. I was happy to be here, and I wish you to continue this level as well. Thank you.
Thank you, Professor Seres. Professor Lubomir, maybe.
Thank you very much. Also, I would like to congratulate the high level of the conference because we have seen a lot of presentation with different level of the research in the nature, and I'm seeing that this research is very useful also for our university, and your experiences are very interesting for us. Our University of Agriculture in Nitra in Slovak Republic, or for our Faculty of Engineering, and mainly our Institute of Electrotechnic, Automatization, Informatics and Physics. So I'm very thankful for your invitation, for very nice organization of the conference, and experiences which are very useful for me. And I would like also, as my colleague, Professor Lavachova told you, I would like to invite you our conference Biotic Spring in the next year in our department, which are 20 years history, and Professor Farka, Horabik, Lavachova, Vozarova are the key persons of this conference. So we will very like to see in this conference. I think that the conference in Bandung had a very high level and very nice level, and it is very useful for the Scopus or next databases publications. And I think it is very good for us to cooperate with our university in the level in the education, also in the research. So thank you very much, and I congratulate you to the conference, and I also wish you the best in the future. Thank you very much.
Thank you, Professor Lugomi. I will give opportunities for the participant from the Malaysia or Surabaya, I think, because I have checked non-Bandung. Maybe you can say something.
Hello.
Hello. Okay.
Hi.
Please. Hello.
Hi.
Yeah.
Okay. I'm from Malaysia. Actually, my supervisor is Professor Dr. Husno, Assistant Professor Dr. Husno, and this is actually my first time joining an international conference after years being a research student. But I'm really actually happy to open an eye to participate in international conference with so many professors, so from many countries, and I really learned a lot actually from all the keynote speakers and everything. Yeah, and I think from Malaysia team, I would like to really congratulate the Dr. Dani, Dr. Jono, and all the committee, all the professors. I say thank you. As a student, I learned a lot, and I really I think everyone here, me or everyone, we really learned a lot. And yeah, just a heartfelt congratulations to everyone, and the greatest gratitude to everyone. Yeah, and I hope to join again next time if there is opportunity. And yeah, congratulations and thank you.
Okay.
It's a good one. Nice. Thank you.
Charles. Greeting from Bandung.
Yeah, makan.
Okay, the other, maybe the last, Dusabe, Simpleste Dusabe. If you, I think you coming from the Surabaya. Okay, the other thing? No? Okay, I think once again, thank you very much for everybody enjoying today's in this FOITIC conference. I just want to say about the outcome from the third FOITIC. Maybe we have discussed with the Professor Susana, we have discussed with the Professor Farkas as well. But maybe after that, we will make about such kind of the MOA, Memorandum of Agreement. It means that we will continue with scientific discussion. For example, we can the circular for the organizing. For example, in Aitenas, we have the FOITIC. In the Godolo, Hungarian University, there is Energy Environment Workshop. In the Nitra, there is such kind of BVS or FRI. I still remember about the FRI, Physics Research Applied Engineering Workshop, yeah, and the Professor Arabic in BVS also. I think we can starting to the circular of the scientific meeting, and yeah, the FOITIC, our Itenas is the host, in the other event who is the host, and we can fixed member, minimal fixed member. So we and Dr. Jono has decided that I know that the Hungary, Slovakia, Poland, and the Czech Republic is the Visegrad 4. Yeah, Visegrad 4. After that, we can continue with the committee group Visegrad 4 plus. It means plus Bandung. Yeah, this is just our our idea. I hope it can be continue with the lot of things. Yeah, today I have talked also with Susana about the possibility student exchange with the Indonesia and the Nitra, because we have done with the Hungary. Yeah, I know that the mobility will give opportunities for students to broaden everything, yeah, to broaden everything, and they will know about the world is wide, it's very wide, and it will give the motivation for the student to know everything. Okay, I think it's enough. Once again, thank you very much for all of participants. Thank you very much for your attention. On behalf of the Institut Teknologi Nasional Bandung, I would like to thank you very much. Thank you very much, and see you in the next event. 2 years ago, I think. Yeah. Okay. Bye-bye.
Bye-bye. Thank you very much. Bye-bye.
All the best.
Thank you.
Okay.
Bye-bye.
Thank you very much. Bye-bye.
All the best. Thank you.
In the future.
Thank you.
Thank
Thank you very much.
Thank you.
Thank you so much.
Ramija, okay, thank you.
Ya, permisi ya.
Ya.
Bos.
Ayo. Siap.
Keren, keren.
Thank you.
Wah, sarut.
Thank you.
Terima kasih banyak Pak Dhani.
Ya, sama-sama Pak Jono. Tugasnya udah selesai.
Alhamdulillah lancar Pak Dhani ya.
Alhamdulillah. Selamat untuk semuanya.
Selamat, terima kasih banyak. Thank you very much for everyone. Thank you.
Untuk fakultas, Bu Pipi.